This is number 19 on page 116. This is another static problem. It's going to be a little more complicated than the guy with the hip. We're going to have to stay pretty organized. Get to there we are. So basically, for something not to move, the sum of the x forces has to equal 0, and the sum of the y forces has to equal 0. That means the right x's have to equal the left x's, the up y's have to equal the down y's, so on and so forth. Well, we already know this is a 150 Newton birdhouse because it's 15 kilograms. And we have two strings. Now we have a string here. If you want to include that, you can, but there's going to be 150 newtons of tension in that string, the same as the birdhouse, so I just kind of skipped over it. So we could hook the birdhouse directly to these two, and it'd be the same thing. And so basically, if we draw our triangles, or if we divide each tension into an x and a y, this one's going to have an x that way, and this one's going to have an x to the left. They are the same size. Whatever this is, that one is. Whatever that one is, this one is. Upward, we have two y's. Sorry, that's kind of crooked, but that's supposed to be in the y direction. Those are two y forces pointing directly up. Those two added together must equal the down 150 Newton force. So if we look at this just from a practical standpoint, we go and get a black up here. Then I'm going to call this FT1. I'm going to call this FT2 because they're different. This angle here is 30 degrees because alternate interior angles are equal. This one here is 60 degrees. Alternate interior angles are equal. So in other words, if this angle is 60, that's 60. If this is 30, that's 30. So if we just look practically at this, then these y forces, this is going to be FT2 sine of 30 degrees. Now if you put in your calculator sine of 30 degrees, you get 0.5. This one is FT1 sine of 60 degrees. And remember, sine of 60 degrees is just a number. You should get 0.8667, so I 0.87 to me. And then this right x force is going to be FT2 cosine of 30 degrees. That's 0.87. And this left x force is FT cosine of 60 degrees, and that's 0.5. So we're going to set the x's equal to each other. So let's write our x equation. F, that's a 1 right here. I didn't put a 1 on that. F T1 cosine of 60 is half, so we'll put a 0.5 out here in front of that. So 0.5 FT1 has to equal 0.87 FT2. I have two unknowns here, so I can't do it. So I have another equation I can use up here, and that is my red ones. The two ups added together have to equal 150. So sine of 60 is 0.87, so 0.87 FT1 plus 0.5 FT2 has to equal 150 newtons. I have two equations here where that is called a systems of equations, so I'm going to use what we call substitution here. I'm going to solve the blue equation for FT1, and that's going to equal 0.87 divided by 0.5 ft2, which is the same as 1.74 ft2. So what I'm going to do is I'm going to substitute this number right here in for ft1, because that's what ft1 equals. So I'm going to substitute that in right here. So basically I'm going to have, I'll color coordinate this, 0.87, and then for ft1 I'm going to put some brackets here, 1.74 ft2 plus 0.5 ft2 equals 150 newtons. 0.87 times 1.74 gives me 1.51. So 1.51 ft2, that's what all this equals, plus 0.5 ft2 equals 150 newtons. Now 0.5 plus 1.51 is 2.01, but I'm just going to say 2.0 ft2 equals 150 newtons. 150 divided by 2 is 75. So I get ft2 equal to 75 newtons. And then once I get this answer, all I'm going to do is I'm going to take this answer and substitute it back up into the blue equation, because I have ft1 equals 1.74 times ft2, so 1.74 times 75 gives me 130, or 131. So ft1, that's a 1, equals 1.74 times ft2, which is 131 newtons. Our answers will be slightly different from the back because we've used 10 meters per second squared instead of 9.8. That's